again. Welcome everyone to the session where we are going to deep dive into one of the BVLOS tech content track. In this session, we will delve into low altitude weather data and why it is critical, particularly for conducting when you're conducting large scale beyond visual line of sight operations. Before we get started, why don't you let us know where are you joining in from and what brought you to this session? What are you expecting at this session? And that's definitely gonna help Dawn as well and us to curate the session better for you. So please feel free to kind of let us know in the Q&A as well as in the chat section what you feel about the session. So the topic again, reiterating, is going to be on how you can maximize BVLOS safety with micro weather services. The current aviation weather infrastructure is mostly designed for human piloted aircraft. High altitude weather frequently differs significantly from the low altitude local atmospheric conditions where drone operations are carried out. And using the same non-localized form of data as a reference introduces uncertainty. Business are often subjected to weather tax, as Don likes to mention, and failure to address this issue results in a fewer flights, customer dissatisfaction, and significant revenue loss. So to discuss on this further, I would like to again welcome Don, the CEO of True Weather Solutions, to the stage. With 35 years of experience in weather, aviation, and logistics systems, he's currently leading True Weather Solutions, which focuses on accelerating micro-weather sensing and prediction for better airspace management for drones and eVTOLs to increase operator mission effectiveness rates and profitability. Previously, he served in the US Air Force for 24 years, where he designed and led Aviation Weather Operations Center, served as an airborne meteorologist, and led all logistics and ground operations at the Manas Air Base, Kyrgyzstan. As a notable meteorologist, Don also led the National Weather Service Directorate for Science and Technology from 2008 to 2012. Don is leading the ASTM F-38 working group addressing issues related to design, performance, quality acceptance tests, and safety monitoring for unmanned air vehicle systems. True Weather was recently awarded a NASA Phase 2 Small Business Innovation Research Grant to design an urban weather sensing infrastructure testbed as a part of NASA Weather Data Infrastructure Initiative. Welcome, Dawn. That's some introduction. So before I pass over the dais to Dawn, I would quickly like to share a few housekeeping rules for the audience. So the session is getting recorded, so don't worry. It will be available for viewing very soon. Please use the Q&A for questions. And do visit the booth, True Weather booth in the expo section if you want to learn more about the product and the services they have to offer. Finally, if you like the session, do drop a LinkedIn post, tag Flightbase, and use hashtag Question23 OpenDIB movement. 3 lucky people have some surprise in store. And I would also like to share my heartfelt gratitude to our title sponsor, DJI Enterprise, and our platinum sponsor, Voltus Airspace, for supporting us in this journey. With that, over to you, Don. Don, do you want me to share the presentation?
Yeah, please do. I want to make sure we don't have any mishaps here. Welcome, everyone. Thank you for joining. I know how busy everyone's schedule is, and I'm hoping that what we could do today is just give you a perspective, a different perspective about what weather capabilities can do to help improve your business operations as well as safety and beyond visual line of sight. There's so much possible that folks don't really understand is possible about what we can do to improve predictions and real-time data collection, because we're used to using the freely available government data, which is great data, but it was built for a different system. So today, what my goal is just try to open your mind up to options. I want you to think about weather as a cost to business. I want you to think about weather as an impact to your revenue generation for clients who are flying aircraft. I want you to think about how if you have a system yourself that you're serving pilots with services, how weather, you can add our weather service as a reseller of our capabilities and upgrade your whole system and differentiate. Those are the main takeaways today. Next, so let's get started with the slides. And I see we got some friends from Scotland here. We're supporting Skyports in Scotland and their medical package delivery. And I see we have folks from Kentucky. We are working with your Mesonet program manager, Jerry Bronsky, to see how we can get some low altitude weather sensors out into Kentucky. So as you can tell, True Weather is in a lot of places, working on a lot of different things. You have the slides?
Yes, I'm trying to just give me one moment. I've hit some sort of.
What I could do. Oh, wait, I got it. Let me take over. I have the slides in here finally. So let me, I'll just take over this point. I got them. I'm going to share my screen and you tell me now. I'm going to ask you the same questions and test you. Okay. So we're going to do we're going to do the window and we're going to do this. And could you see my screen?
Yes, we can see your screen now. Thank you.
Awesome. So we have a little poll question in here that I'd like you to, if you don't mind taking it. It really is, the question is, have you calculated the cost of weather on your operations in terms of maintaining safe flight, lost productivity, and revenue? What I have found in my career, 40 years, is that most people really don't know the cost of weather on their operations. The lost productivity, times that you could fly and you're not flying, getting some bad sensor data that you could have gotten if you picked a better weather window to fly. Those are all costs, right? And generally speaking, weather will cost you about 10% of your operations budget. So if you look at your flight operations budget, weather is about 10% of that cost. And it depends on where you live. If you're in Boston, it's going to be more like 20. If you're in LA, it might be more like 8. But it averages out to that amount. And that's a real cost of doing business. And it's something that most people have accepted as the cost of doing business, right? They're using the weather service products or service products, and they're just assuming that's the best we could do. And they don't want to pay for something they don't have to pay for. So they just go along with that. And what I'm going to tell you is that that's not really the case, right? We know that 30% of manned aviation flights today, or crewed aviation flights, canceled or delayed due to weather, could have flown. The uncertainty about what's happening, and we've been working with some drone delivery companies, and they've actually come over to True Weather because we recognize that the way you, not only the accuracy of the weather data, but the way you consume weather data is really important in how you make your decisions and whether or not you're going to make good decisions about whether to shut down operations or keep operations flying. We know that 60% chance of rain in the next 2 hours is not going to help you make a decision about whether you should fly or not, right? You need more certainty than that. So what happens is you wind up canceling because you hear about 60% chance of rain and it doesn't occur. And that's because it may be raining around that area or other places. The whole idea is to get the micro weather better and right so that you can have less uncertainty, and then you can then take advantage of the flight time you can get in order to generate revenue. So what I was in the Air Force, and what we did in 2001 is we demonstrated that how you use weather data in operations matters, right? We had been flying 100,000 missions a year for the Tanker and Airlift Command around the world to move cargo and people and fuel. And we had 5,000 weather days a year of 100,000 missions. What we did was we changed how people integrated that into their risk management framework. We helped them better understand what weather data was more accurate and which was more uncertain. And we targeted that, and we cut in 1 year, working with dispatchers and planners, we cut the delays to 1,800. And all we did was change the way people use the data. And that's really critical because we have so many operators out there that use different weather data, use different processes, and really they don't have insight on what's possible. They've only been operating within the framework they've been operating in, right? So you almost got to change your mindset about weather if you want to regain some of that flight time or make better decisions, as well as get better low altitude measurements. So why is this becoming more important than, say, manned aviation? Well, that's because we all know uncrewed aircraft are lighter, they're electric powered, they're more weather sensitive, right? You can only travel a certain amount of distance. You can't add more fuel. So it's either going to be taking off weight, losing schedule, or trying to maintain schedule and using more power to stay in the traffic flow or in the volume reservation you've recorded, right? And there's a lot of weather hazards out there that today are unknowable. You will never see them on a weather chart. I mean, that's why pilots get surprised by weather, right? But the difference is pilots are on the aircraft and they learn through heuristics about different local effects. They learn about where our accuracy isn't as good. And then they can also take action if something happens. Well, when you have a no air crew on the aircraft, you've lost all those heuristics. And eventually, unless you're flying in the weather, there's no way you could be as effective as you are today having a pilot. So we have to close the data gap now. The only way that we're going to be able to make up for the loss of the pilot is by closing the data gap. And the current weather systems are too coarse for that, right? We just don't collect enough data. So what's going to happen is the lack of a pilot, more BVLOS, flying one to many, and this uncertainty is going to drive more difficult decisions, and it's going to cost money for you because you're going to have to be more conservative in order to make sure you don't have an accident, right? So the problem is really in the low altitude. Below 5,000 feet, the satellites do pretty good at picking up weather information, and satellites and balloon launches and aircraft flying at 30,000 feet are all important reasons why our forecast accuracy has improved over the last 30 years. The problem is that once you get below 5,000 feet, there are very few weather measurements. Most of the time when you're looking at weather data above the ground, below 5,000 feet, it's model-based. It's not real data. And so there's a lot of errors in it. We have a lot of trouble with ceiling height with our models. We have trouble with our visibility forecasts. Even in current weather, we don't know exactly where the low visibility is in fog and valleys and things like that. So when you start flying beyond visual line of sight, you could be going from VFR to IFR to VFR. Same with the winds aloft. There's 50 to 70% errors in our modeling versus the real-time winds. So that's all going to add up to money over time. It doesn't mean you're going to crash airplanes necessarily, as long as you're careful and you're conservative. But the conservation is what's going to cost you money, right? So we want to close those gaps. We want to increase flight time. We want to increase revenue, and we want to do it safely, right? Safely. So our goal generally is that we want to maximize your revenue per airframe by flying in as much of 100% tolerant weather conditions as possible, right? And the better data we have, the more knowledge we have to help understand safely where those windows are. We want to make sure we can provide enough lead time for you to alert when these windows are going to close or open up. Because, as we've been working with a drone delivery company, it's not just about what's happening right now. You usually need to know what's going to happen an hour from now, because you're going to be loading cargo, aircraft, you're going to have people working, you're spending money, and then all of a sudden they say, oh, you can't fly. Now you've disappointed your customer because you're not going to deliver when you say you will, and you've done a lot of work that's not generating any revenue. And then we also want to talk about this power problem, optimizing power based on the winds aloft and knowing, how much weight you're going to be able to carry, how fast you're going to get to where you want to go. And when you're starting to run a high density operation for drone delivery, or you're doing any other kind of drone operation that requires a schedule, once you start having these missteps in our forecasting affecting your ability to operate smoothly, you start introducing a level of chaos in your logistics and supply chain. I'm an expert at that. I ran an Air Force base in Central Asia. I ran the main staging base in Afghanistan. All the cargo, all the people flew through my base to Afghanistan. And I know when you have a logistical plan and you're trying to generate revenue and turn aircraft and get packages delivered, you want to have as much visibility and anticipation of what's going to happen. And yeah, it does cost money for that. But what I will tell you is the ROI is worth it if you change the way you view it, right? You can't look at what the cost of weather is. You got to look at it, what's the value in your, down to a unit cost of more flight time, more revenue generation versus what the cost is overall to your system. And I almost guarantee there's a 4 to 1 return on investment waiting out there for folks. And then finally, if you're talking about optimizing flight safety, We also want to worry about, for eVTOLs, passenger comfort, right? And air sickness. So, you don't want to, you might be able to engineer your aircraft to fly in certain weather conditions, but you may not be able to engineer the user's stomach to fly in those weather conditions. And that leads to a bad experience, right? So everything we're talking about here in weather is we're talking about more productivity safely, more targeted flight times, better predictability for your clients about when and if they're going to get their packages, and better predictability about your clients, if you're flying them in an eVTOL, about whether or not they'll be able to get from a vertiport to an airport in the amount of time necessary. Because by the time they show up at a vertiport, if the wind's picked up and you have to drop weight on that aircraft, you've just impacted their whole travel schedule. So that's the way we're focusing on this, is by trying to improve data collection. And we call it from the ground up. And it's not me. This was a study done in 2008 by the National Academies in the United States that said, if you really want to improve micro weather and understand what's happening in the lowest 3,000 to 5,000 feet, you have to have a network of 400 ground-based profilers that could go up and measure temperature, wind, and moisture on a regular basis. Today, we have 2 balloon launches a day at 77 locations in the United States. The same principle applies overseas. So wherever you are, it's about the data. And if you want to really improve the onset of fog, the dissipation of fog, the onset of low ceiling, the possibility of thunderstorms or showers popping up, winds aloft, and then even further, understanding what those winds are going to do in urban canyons, it really takes a more customized approach in order to get more predictability. So we're focusing on the low altitude. And we're experts at this, right? We're logistics experts, we're weather experts, and we're low altitude experts. And we're taking on the hardest problems. Most weather companies will not take this problem on because it is very difficult and it does take a little effort, right? But we are taking it on because we recognize that the drone and air taxi industry is going to require this, and it'll be the best business case ever for micro weather. And everyone will be able to benefit from this because as we get our sensors out, we're going to be able to amortize that cost across lots of users. So imagine over an urban or suburban area, we start flying thousands of drone missions a day. That cost of these weather services will drop per user because we're now going to be sharing information and sharing that cost, which will increase everybody's uptime. So we know how to achieve these results because we've showed it in the military. And what we've done is we built a platform that could take all these data sets, including new sensor data, integrating that in, and then feeding that back out, customized by location, right data, right time, and giving you a much better picture of what's going to happen. And then we can layer that with forecaster services also. So if you have some really expensive decisions to make about not flying or flying, we have a 24/7 operations center that you could talk to a meteorologist when you want to and only pay for when you talk to them to help them make those decisions. Sometimes those could be $10,000 decisions, and it might cost you $75 to talk to a meteorologist. You see the return on investment. We also know how to, work with you to eliminate the cost of weather and amplify your ROI. And we also want to talk about how we fill these gaps in sensors, and we could do analyses for folks. We don't want to put out more data sensors than we need. We look at what's available, we look at the gaps, and then we make recommendations about how to fill those gaps. And we bring all that data together in a single one-stop shop. So I'm going to just run a quick video here for you of one of our customers. I'm Don Burchoff, CEO of True Weather Solutions. So the big challenge with drones and air taxis is that there's no pilot on some of these aircraft. The pilot is the best weather sensor we've ever had on an aircraft. And if you talk to helicopter pilots, they'll tell you how many times they run into undetected weather. We don't see it in our current system. True Weather is a provider of micro weather data services to advanced air mobility and the drone industry. One of the great things about True Weather is that they're innovating in an area that is critical for UAM. Skyway is a navigation PSU. You can't do navigation without knowing what the weather's going to do. Our job is to get them the best micro weather data to identify hazards or any kind of an event that's going to impact their ability to navigate the sky safely. True Weather gives us high resolution, low altitude quality data so we can give the best navigation experience to our customers. We're flying a weather instrumented drone. This is one of 6 sensor types that we have. This particular drone will go up and take a vertical profile of the atmosphere. It will collect data on winds, moisture, but more importantly, it can fly in clouds to detect icing. This is going to become a major problem because we over forecast icing today in our models. So we're grounding aircraft sometimes unnecessarily. This drone is going to go up in real time and see if the icing's really there. We're going to do a hub and spoke system. You have a high quality sensor that can give you height of clouds. And around that, you have cost effective sensors that can pick up winds in neighborhoods, which are going to be really important if people are delivering packages and they're dropping them from a loft. We're going to array those sensors in a way that gives us a microclimate view so we can be predictive about how those weather effects are going to change over the next 6 hours and help become more reliable about scheduling assets and people and having customers know when and if they're going to be able to get the goods that they've ordered based on how the weather's going to behave that afternoon. My vision is True Weather will be the UAS industry's weather provider everywhere in the world. I'm Don Burchell. So that again just was Skyway is one of our partners. They're an airspace navigation system. They view us as a partner. Most of the companies I work with view us as a partner, not as a weather data provider. If you just want a weather data provider and you could tap into any API, you can get that. But the problem is that's not going to meet your requirements. So this is about a full end-to-end capability that brings the sensors in, fuses that data in a certain way. And also we're working on the ASTM F38 weather standard right now. We should be going to ballot for the first round here in April. I've already been working with Canada, Israel, and other countries to bring this standard into their areas. And what we're going to be doing is working with customers out there in different countries that want to try to leverage this kind of technology in their systems and to build waiver packages to say, let's test this new standard, which is a data performance standard. You don't have to have an ASOS, $250,000 ASOS. You'd be able to have one of these instruments that are lower cost, that are still very good, and they work for the mission that you're flying. And so we're working the whole problem from the policy and the standard to the sensors all the way to the solutions. And we're offering that through APIs that are simple to use. We have them today. Our system's going to get better over time as we get more data in it. And we also will bring that meteorologist in as required. So just to show you, we're working in Hampton, Virginia now. We've installing 2 scanning wind lidars. These lidars can see dirt and dust and back out Doppler technology, and you can watch the winds blowing in 3 dimensions all the way up to 6,000 feet, covering a 20-kilometer area with the 10-meter resolution. And what that's going to do is it's going to give us unmatched situational awareness about winds above the ground, which will give you almost 100% true understanding of what the winds are going to do to your mission, which can be incorporated into your analytics and help improve your mission planning. But this is an example. We'll be running these CFD models with our atmospheric models in 2024, 2025, that will actually start understanding how these buildings will impact the winds, with the orange being stronger winds, and how you can avoid areas with good information that are not going to be very, not enable your capabilities, but maybe hurt your capabilities, right? So this is where the science is going. This is what the technology provides. And again, this is the value that could be, weather could add to your operation. So I think that's it for us. I think that was the last slide. I think we have another question that you might want to answer is, has this presentation helped you view weather differently? And do you see the possibilities now, what weather can provide? Thanks a lot. And I think we have a couple of minutes for questions.
Yes, thank you again, Don. That's been a very insightful presentation.
Thank you. And I'm here to answer questions and talk to people. And
yes, so again, I have a lot of questions already, but in case anybody has any more questions for Don, please drop them in the Q&A. I'm gonna open the house for questions. So I'll start with some questions that are already in. Okay, let me just go through them. So how can users get started with True Weather Solution? What's the business model like?
So we have a SaaS platform. We have two ways to deliver information. One is through the APIs, which you can get an endpoint, tie into those. We're more than willing to let you demonstrate capabilities. Before you ever get into a business with us, we'll give you a testing and demonstration time. You can look at the data. And that would be for integration directly into your system, whether it's a command and control system or a decision system, or another service provider who wants to integrate our data into their system. If you want to integrate our data in your system and you want to make our data available as a service to your system, we work with you on a business model on that, where you can resell our capabilities to your system, right? So that's one way. The other thing is that we have a dashboard. We do have a web dashboard. Now, we're working on upgrading that. It is available today. You can purchase it for, I think it's $150 a year, which is not very expensive. And it's getting better and better over time. If you want to use the dashboard, you could buy a sensor yourself. And if you buy that sensor, we'll plug it in and you'll be able to see your sensor in our dashboard with all the other data we have. That's one of the few weather companies that could do that so affordably. So those are the two ways you can get to us today.
Thanks, Don. I think to add to the question, the sensor that you mentioned, is that available? Is it off the shelf, or is it something that you've customized and provide?
Very good question. We don't believe in building sensors. We want to get the best of the best technology. The way True Weather has built our system is we want you to think of us as the Uber integrator of the best of the best. So even some of our data we're getting from our best partners, because True Weather realizes this is a big problem. So we actually have a list of sensor providers that we would share with you and say, look, here's the ones that are already integrated into our system. So if you want to purchase one of those, we'll work with you. We'll purchase that. We'll get that in there, and we'll start providing you the services back. If you want a sensor that's not listed in our package, we would look at that, and if it looks like a sensor that is going to be a sensor other people will want, we will integrate that, and we won't charge you for that, because we know that our business model is to resell data and the plug and play of the sensors.
Right. There's a question around the software again. So is it mostly an online software?
Yeah, so it's software as a service, really. I like maybe call it data as a service, right? Because our software runs, our Fusion engine runs so we take in all this data, we then, aggregate it, we put it into the right bins, and then we run our analytics. And then you come in with a request for a piece of information at a location. We go in and we build your solution for you on the fly, and then send it back to you with the best data we have available or the best data you're purchasing from us. So we have different tiers of data. You can have a standard package, a premium plus. And the more granularity you want and the better solution you want, you pay a little bit more for it, right? But we have that business model for you to buy what you can afford. And by the same token, you can also buy forecaster credits. So if you need twice a year or 3 times a year, you go, man, this is an expensive decision. I'm going to call True Weather. You give us 30 minutes notice. We'll come back to you with helping you make that hard decision about what's happening between the lines around the forecast that you don't know, but we know, right? We know what the models can do and how bad they are sometimes. And alerting, we're going to have an alerting capability. It's not out yet, but it's going to come out in the next couple of weeks. And we'll be able to watch weather for you in some areas of the world. Not everywhere yet, but we can operate everywhere in the world. We just have better capabilities in certain parts of the world, right? So we would work with you on that.
Right. A follow-up question to that is, because you mentioned data. So is the data that you're talking about only available for the US or other geographies too? We have a question, for example, is it available in Israel?
Yes, good question. And we can do it in Israel. I just visited Israel 2 weeks ago, and I met with the CAA, and I know you're running your air trials, and I was out there at Yisham at the air trials. Yes, we can provide services anywhere in the world. We build it out. We connect to the data sets we need as we're getting customers, right? So it's like it's like a cell phone service, right? If we have enough work in Israel, we're in Israel, right? We're even working with trying to get sensors in Israel. We've been talking to some partners in there. So yes, the answer is we could go anywhere. We're in Australia now. We're in Europe. We're in Scotland. We're in the UK. We're in France. We have the ability to go anywhere. Like I said, the quality or the amount of really good data is going to depend on what part of the world. But we can always bring in a solution that would be the best anywhere in the world, right? We can do that. We can run models. We can bring in sensors. So don't limit yourself. Now, what would limit that is the budget, right? So, but if you come to us and say, hey, we got a business case here in Dubai, and we are talking to folks in Dubai and in those areas, we can always work a solution if we can find the business case.
Right. Just lost the Q&A tab. Yes, great answer, Don. So I think you've already covered in this presentation. However, are there any challenges? I mean, what are the challenges that are associated by using high altitude weather? Like if you could mention some of the shortcomings that you have noticed, or some major problems that you've noticed. And if you could share some anecdotes with some customers or somebody who you've heard from, challenges that are with high altitude weather as compared to when you are doing operations in low altitude.
Low altitude. Yeah, I got it. So we've worked with a couple of companies doing high altitude operations. The big challenge in high altitude is not necessarily when you're at 60,000 feet, although there are weather impacts. They could be weather impacts at 60,000 feet. But the big challenge is getting up and down, right? Because usually when you're flying with these type of aircraft, they either have large wingspans. They can't take the same amount of crosswinds when they take off and land. So the big challenge is getting it through the atmosphere, right? So you have to target that window to make sure that you can get to altitude and then get back down. But at altitude, there are some challenges up there, like thunderstorms that grow above and get through the tropopause, which could cause some turbulence. There's some other issues up there. Winds, though, generally aren't a problem because once you get above the tropopause in the stratosphere, the winds calm down. But I find we're working with some companies. We can help you with that problem. If this is something you need better services for, we definitely know how to do it.
Right. Let me check. Okay, so there's another question around what are your primary source for data set? Do you take inputs from GFS and ECMWF? Also, how do you deal with microweather uncertainty?
So I prefer not to use GFS in European model because they're not high enough resolution. They're only, the European model is 9 kilometers. It's a great model. I'm not criticizing the model. These models are great for what they do. But when it gets down to 1 kilometer or less resolution, which is really micro weather, they can't pick that up. So what we do is we sometimes will take those models and we'll downscale them, and then we'll add new data, and then we'll try to get the micro weather better. So the way you increase the certainty associated with low altitude weather is you have to get better data in there. Then you got to run another model for the forecast. So what we do is we try to get the better data first, right? Because if we have a good picture of what's happening, that's even a big improvement of what you have right now. Because right now you really don't know what's out there because our models aren't good enough. So you get that first. Then as we get enough data, we can run a model that takes the initial conditions from those GFS or the European models, and we run them down to 1 kilometer resolution with the new data. And that's how we really get a better picture of what's happening. We're doing that in Hampton, Virginia. We're going to have 2 scanning wind LIDARs. We're going to take the HER model in the United States. We're going to run our models, and then we're going to put our data into there. And with this high resolution wind data that's unmatched, that's going to make the forecast from 0 to 6 hours tremendously better than anything you can get from the European model or the GFS.
Right. That makes sense. There's one other question. With the drone that goes into clouds to take icing measurements, how are you getting around the VFR requirements here in the US? Or is that a future capability once BVLOS is legal?
We're working the waivers with the FAA. We've now got up to 3,000 feet, not in clouds yet. Up in North Dakota, we're working with the FAA in the Indianapolis Center. We have an area that has a detect and avoid radar. We're working on a military restricted airspace area, so we have some advantages. We will be able to get that waiver in cloud, but again, you have to be able to show where your aircraft is, right? And you have to make sure you have clearance with the FAA if you're going to go above a certain height. So we're working that right now. And my strategy is we're going to get these drones out in other places. There's other tools to see icing, by the way. We have another tool that we're going to start using to be able to look up with a LiDAR to see the size of water droplets. If we could see water droplets in clouds and we know it's below freezing. We're working this icing problem really hard because we really do need to improve that. But yes, we're working through all those issues right now and learning a lot about them.
Right. I think we are almost close to the end of the session.
What's open DIAB approach? I'm sorry, I don't know what that is.
So that's a question that actually the flight-based team is going to ask, and we've been asking this to all our speakers. So the theme of NestGen is the theme that we are promoting this year is open DIAB approach, where we're bringing in companies with different technology stacks that are contributing to different layers in the drone autonomy, the industry. And weather is one of the layers that are in this, part of this industry. So what we want to, ask all our speakers today is, do you think that having this kind of a layered approach instead of a monolithic approach is better, and what are the benefits and how can it help us grow in the industry? Like, for example, we know that you've partnered with Iris Automation and different other such partnerships to bring in all the different experts to form a complete solution. So what are your thoughts on that?
So everything, I was in the military and everything we did was joint operations. And if you want to get the maximum use of weather data, it needs to be integrated with other data sets to run analytics. And that's how you're going to get the maximum value of it. So I think that there is no doubt that the better we can bring different components of services together, and we can then run these together in, first of all, just from the simple GUI perspective, like to be able to see your volume reservation area versus your weather versus maybe your drift that you're going to have versus the alerts that come out from that. That helps from that. But even in a machine to machine, when we move the machine to machine, which is where we're going, it's going to be digital, right? We'll be able to bring all these data sets together and run an analytic that gives you like a perfect best estimate of the best operation that you can run. And for weather, I hate to say it, but weather is the last thing that matters, right? Because you can have a perfectly planned operation. You can have the best communication, the best remote ID, the best engineered aircraft, and then the weather guy comes along and says, oh, you can't fly, right? So you want to make sure that, all this is being integrated so you can make rapid decisions and updates. So that's a great question.
Thanks, Don. I think one thing that I've easily learned from this session is most of us ignore weather and they just consider it as a cost of doing business, like you mentioned it before. So this is going to really open people's minds and they were going to start taking seriously that this is something that they should consider and not just, venture out for an operation only to get it canceled because they did not have the correct information. So thank you again.
Yeah, just one thing, I'll let you go. Weather's not a cost, it's an enabler. And you've got it, and we shouldn't be thinking of weather as you have to hit your checklist so you're allowed to fly. That's the wrong attitude. What you want to do is think about how do you get it integrated in there to get more benefit to your company. And I think that's a real big change in the way we've been operating for years. So thanks for this. I really appreciate it.
Thanks again, Don. Before we close, do you have any closing thoughts for the audience today?
I think that, first of all, I see some of the, it makes me happy to see 3 people said they learned something today. So thank you for that. I appreciate it. No, I just want to tell you, we're here to help everyone and enable this industry. This is more than a business to us. This is a passion. We want to unleash the power of science and technology that has been trapped. and we want to get it out to the commercial sector. And we know the challenges of getting data, getting government data improved. It's just not, that's not going to be the vehicle in the future, because it's just bureaucratic and they don't have the resources. So this is the way we're going to do it. And we want to work with lots of companies to get this cost down. So the more people we're working with, the lower we can get our costs down. So we hope that you'll, take that to heart and contact us and let us know if you need anything. Thank you.
Great. Thanks again for enlightening us, and to the audience out there, thank you for joining our session. We have networking and booth visits coming up next, so please visit the networking tab or the expo tab if you would like to explore some latest technology in this space. Thank you again for joining in. I hope you have a great day then.
Thank you everyone for listening.